Hey everybody, this is Mr. Bullock here, and this lesson is on problem solving with linear inequalities. Okay, so we're going to stretch our knowledge here a little bit, but before we do, let's go over some math symbols, okay, that you guys are probably familiar with most of them here. So we're going to make a table here, so we've got some math phrases and then the symbols we use for these math phrases. Okay, if you see the word is in math just means equal, okay? So if I said 5 plus 7 is 12, that would be 5 plus 7 equals 12, okay? Greater than, okay, well that just means it's this symbol, so that is greater than when it's pointing to the right. And when it's pointing to the left, that would be less than, okay, so there's less than. Okay, at most, you guys, well if it's at most, say I had at most $50. Well, at most means I'll have up to $50, so it could be less than or equal to, so less than or equal to. Okay, at least would be greater than or equal to. So if I had at least $50, I would have $50 and or more. All right, easy enough. So let's translate each phrase into math symbols. Here's the first one, 7 more than x. Okay, more than is an addition problem, you guys. So that would be x plus 7, okay? And typically, you guys, when they say this, the 7 usually comes second right here, especially if you see something like this, you guys, 2 less than y. Okay, it's not 2 minus y, it is y minus 2. So say I said you had $2 or 2 less than $10. Well, that would be $8, okay, and you get 10 minus 2 is 8 on that. So 2 less than y is y minus 7. Not y minus 7, y minus 2. What am I talking about? I'm looking at the thing up above. I'm sorry, you guys. That should be a big 2 right there, okay? 5 decreased by y. Okay, this one is read just like you see it. This is going to be 5 minus y. So if I said 5 decreased by y, I have to change that. It's 5 minus y, okay? So just kind of watch the wording right there. Okay, and then so if it's 5 decreased by, then you read it just like you see it. If you see 2 less than, then the 2 comes second right here. And 7 more than, the 7 can come more than. You can write this one as 7 plus x also on that, okay? All right, let's try this. So your friend has at least 2 more dollars than you have. So we're going to write a t-chart for how much money each of you could have, okay? So then write an inequality to model this, and then we'll graph this. Okay, so let's make a t-chart here. So here's you and your friend. And right here it says your friend has at least 2 more dollars than you have. Okay, so let's just do an example. Say you had $2. Okay, your friend has at least 2 more than that. So they could have $4. But they could have more than that. They could have $5. I didn't put a dollar symbol there. That's okay. They could have $5.50. They could have $5.51. It could be $10. It could be anything more than that. So anything more than that. Okay. So if it asked you to graph this, you'd graph 2 comma 4. You'd graph 2 comma 5. 2 comma 550. Okay, I'll show you a graph on all those in just a second. Say, what if we had $4? Okay, your friend starts it's at least 2 more than that, so it's going to be $6, okay, or more than that, 6 or 7, or more than that. Okay, so 812. I just put using as examples, you guys. It could be 837, or doesn't matter. Just something that's 2 more than $4. So any of those numbers will work right there. Okay, if you started with $6, then your friend is going to have $8 or more than that. Okay, anything above 8. All right. So this part says then write an inequality to model this and graph. Okay, I'm going to let you be x, and your friend is going to be y. So if your friend is always 2 more than you, then it's going to be it'll be x plus 2 has to be less than or equal to your friend. Okay, so your money plus $2 has to be less than or equal to whatever your friend has. Okay, because you got to always add $2 to match up with your friend right there, and your friend is y. Okay, and you're x. All right. That makes sense, you guys? Kind of, sort of? Okay, now what I did was I did the symmetric property. I flipped them around the inequality so it looks like y equals mx plus b. Okay, notice the inequality here is pointing away from the y. Just make sure it's still pointing away from the y. So when it gets flipped around the inequality gets flipped around also. Okay? Notice again, it's pointing away from the y, so it still has to be pointing away from the y, okay? And then I flipped, I made this x plus 2. Well, here's my x plus 2 right there, okay? All right, so let's go ahead and graph that. That was from our last lesson, so let's graph this right here. So y is greater than x plus 2, okay? I'm going to go ahead and graph the plus 2 right there. I'm sorry, I didn't put any numbers right there for scale, so that would be 2. And then the slope, you guys, the slope right here is 1, so I'm going to go, which is 1 over 1, so I'm going to go up 1 to the right 1, up 1 to the right 1, okay? Solid or dotted line? Okay, that's what I asked my class on the last lesson. Is this solid or dotted right there? Well, the equals bar says it's going to be a solid line right there. Okay, so there's a solid line. Then we shade. We're either going to shade this side or we're going to shade this side. So I'm going to test 0, 0 right there. So now test 0, 0 for the shading part. So is 0, I just plugged in 0 right here and 0 right here, is 0 greater than or equal to 2? Is 0 greater than 2? No. So we're not going to shade this side. We're going to shade the other side over here. So there's all the answers that would match that right there. All right, let's try another one. There are at most 50 jungle beans in a package. I didn't make this up. Another teacher did, so I don't know where she's getting jungle beans. Okay, jungle beans can either be brown or white. Okay, so write a T-chart for how many of each color you could have, and then write an inequality to model, and then graph. So just like before, you guys. So here's my T-chart right here. Okay, we can have at most 50 jungle beans. So I just put in 10, 15, and 20 brown of them. Okay, and then right here can have at most 50. So here's just some examples, you guys. I chose 11 because 10 plus 11 is 21. So that's at most 50. Yeah, that's less than or equal to 50 right there. At most is less than or equal to. Could have 20. In fact, I can go all the way up to 30, you guys, and because that would get me, I can go up to 40 also. 10 plus 40 would be at most 50 right there, and I don't know if I did 40 right there. Yeah, I did. Okay, so that's it. That's as far as I can go up on that one right there. Okay, well, 15. I can have 16, 30, 35. Now notice 15 plus 35 is 50, so I stop at 35 right there. Okay, 20. 20 plus what equals 50? Okay, so I'd have to stop at 30 right there. So it doesn't have to be these numbers. It could be 21, 22. It could be 1. You know, just the brown plus the white has to be at most 50, and 20 plus 1 is less than that. So that would fall under the category of at most 50. Okay, now I could have chose X and Y, but I'm going to choose B and W for brown and white, you guys. So B would be the brown and white would be W would be the white. At most, less than or equal to 50. Okay, so just think of B as X and W as Y, just like alphabetical order. X comes before Y in the alphabet, so B comes before W in the alphabet. So let's go ahead and graph this guy. Now instead of having X here, I'm going to put W here and put, B here, because X is before Y in the alphabet, so B is before W in the alphabet. So I'll put W up here. So let me go ahead and cross those out. And then since it's and we'll just think of B plus W equals 50. Okay, and so my scales are going by tens on this, you guys. So I'm going to go ahead and do the intercept method. Okay, so when B equals 0, that would go right here. Then I have 0 plus W equals 50. Okay, 0 plus W equals 50, so W equals 50. So there's 0 comma 50 right there. Okay, and then when W equals 0, then it's going to be B plus W equals 50. Or, whoops, I did a little bit too much. Well, that's okay. So B equals 50. So then I go ahead and connect those two guys. There's the line right there. It's a solid line right there because it's less than or equal to. You guys with me? Okay. So then test 0, 0. 0, 0 is on this side right here. And since 0, 0 made this guy a yes, then I shade the side 0, 0's on. You ready? Here's the whole side. It's shaded right there. All right, so give it a shot on this and make sure you ask your teacher some good questions, and I will certainly be happy if you ask me some good questions. Okay, take care, everybody.